Okay, so now we are going to start by talking about derivatives. So when we talked about limits, it gave us the y value that something was approaching from each side. A derivative is essentially the way of giving you the instantaneous slope, meaning at any given moment, it is giving you the slope. Now, the slope formula that you already know is y2 minus y1 over x2 minus x1. That's called the average rate of change, meaning that over a given amount of time, what is the slope? Now, when we're talking about a straight line, the average rate of change is the derivative. But let's think about a quadratic. If I want to find the rate of change between 2 points, it tells me this average rate of change formula is giving me the slope of a line connecting those 2 points. But that slope is not the same as the slope from these 2 points, right? So the average rate of change varies depending upon the points that we choose on the function. Now, what we talked about with limits can be applied to find a more accurate rate of change by finding the values. What we're looking at is the limit as, the limit as x approaches h, as h approaches 0. So basically, this is just you don't necessarily need to know a lot of this, but the fanciest way of saying this is that you're looking at comparing two values as that distance, that average rate of change is getting smaller and smaller. So what this is saying is when we're looking at these 2 points is where this point and this point, the h value, that difference between them is really large. But what if we looked at this point, green point, and this blue point? They're like basically right on top of each other. So finding the smallest interval we can. So that's still a whole lot of work. If I were to write out the limits and show my work for that, it would take me a very long time. So what was developed is the derivative notation. Now, derivative notation allows us to do something very quickly. It looks a lot more complicated than it is, but I'll go ahead and write it out first. So if I have a function f of x is equal to x to the nth power, then the derivative, or f prime of x, which we also sometimes call dy dx, which is delta y delta x, which is the change in y divided by the change in x, which is this formula up here. But this allows us to do it at any given instant, not over a wide amount of time. So this formula, f prime of x, our derivative, would be equal to n times x to the n minus 1. Now, that looks a lot more complicated, but all you're doing is bringing down the power and then raising it to the power minus 1. So if I have x cubed, then the derivative would be bringing down the power and then subtracting 1. It's pretty straightforward, and you'll get lots and lots of practice with these derivatives. So that is the function for the slope at any given moment on a curve. Now, if I were to ask you what f prime of 2 is when f of x equals, let's change it up a little bit. We'll do x to the 4th. I'll even 2x to the 4th. I want to, basically what I'm asking is what is the slope of this function at 2? So what I do is I take the derivative. So taking the derivative f prime of x, I'm going to bring down the power. So 4 times 2 is 8. and then I subtract 1 from the power, so this is 8x cubed. And now, just like in algebra, you're going to plug in 2. So I end up with 8 times 2 cubed, which is 8 times 8, which is 64. Okay, pretty straightforward. It's just finding the slope at any given moment. This also helps us find our extrema. Now, extrema is your maximums or minimums. And when you imagine a picture of a maximum, if you were to find the slope at this given point, it's 0. So what we can do to find the max or min is set our derivative equal to 0 and solve. The same thing works for our intervals. If a problem asks you, where is the function increasing? If you don't have your graphing calculator, which you won't on the first portion of your test, of your IB exam, the best way to figure out where a function is increasing is to find where f prime of x equals 0, and then do a test on each side to see if the slope is positive or negative. Because if the slope is positive, then that means that interval is increasing. If a slope is negative, then that means it is decreasing. And we will get lots and lots of practice with all of this. I know I went pretty fast, but we will do lots of example problems on Delta Math. But that's it for your first derivatives lesson.